Our next lesson in pre-algebra is called Introduction to Sets. Our goal is to review the basic concepts of set theory. Let's look at our vocabulary words. Okay, I'm going to read a definition and then say the word. I want you to repeat the word after me. Are you ready? An object that belongs to a set is an element. A set without elements is an empty set. Any set whose elements can be counted is a finite set. Any set whose elements cannot be counted is an infinite set. A set that has no elements is a null set. So an empty set and a null set are the same thing. A collection or group of objects is a set. Alright, so if I ask you, what is a set? Okay, well, we know that a set is a collection or a group of objects. They can be items, numbers, ideas, they can be almost anything. Each object in a set is called an element. Okay, so I want you to go ahead and get your notebook for pre-algebra. Go ahead and write today's date. And our lesson today is called Introduction to Sets. Okay. We said that a set is a group of objects and elements is each object in the set. I'm going to put item because they're not always objects. Each item in the set is an element. Because if I have a set with a set of numbers, 1, 2, 3, 4, those aren't objects. Those are symbols. Okay? So I'm going to use the word item. In fact, here, instead of object, I probably should have used the word item there, too. Okay, so an element is a member. Okay, so how do we enclose the elements of a set? If I have my set of numbers, 1, 2, 3, I have to put braces around them, and this is what braces look like. They're not parentheses, they have the little point in the middle, but these are braces. Those are arrows, by the way. But those are braces. If you have a set, okay, like this one, it has the 3 dots. That means I write the first 3 items or elements to establish the pattern. Then I just put the dots, and you know what the rest of the set is by the first 3 elements. Okay, now in this set, can I count the elements in the set? Well, 1, 2, 3, but this means it keeps going. So I can't count these elements. So this kind of set is an infinite set. Infinite set means you can't count the elements. You can't count them because they go on and on and on. Numbers keep continuing. They never stop. A finite set would be the opposite. You can count the elements. Okay. All right. Now we're going to talk about another kind of set. The empty set or null set is a set that has no elements. Now you have to remember the empty set and the null set are the same thing. Okay? they have no elements. It can be written like this. See, there's no elements there. Or you can write it like that. Usually we don't use this in class because we don't have a key on our computer that looks like that. This is a symbol of the Greek alphabet. Or you can just write the word empty set or null set. So all four of those are ways to write the empty set. You can say empty set, you can say null set, you can use the braces, or that symbol. So there's four different ways we can write that set. Okay, for example, if I said, write the set of female presidents of the United States of America, well, that would be the empty set. We have never had a female president. Okay? Now there are different ways to describe sets. There's the roster or list method, which is what we did here. We used braces. This is the roster method. And it works well with infinite sets. Finite sets. It works well with finite sets when you can count the elements in the set. I'm getting ahead of myself. Let me go ahead and write this down. Okay. There's the roster method. It's also called the list method. And this is, like I said, this is what we've been doing. We use braces with finite sets. That totally took me off guard. Okay. To use this method with infinite sets, use 3 dots to represent the fact that the elements cannot be counted, which is what we did here. I'm sorry. You don't have to write that. But it uses braces and it lists the elements. That's why it's called the list method. Okay? But there's another way that we can describe sets. We can describe sets using the the rule method. I don't know if we've talked about this before or not. The rule method, instead of listing the items, it shows the rule for them. For example, if I wanted a set of numbers, I could use I accidentally put a parenthesis there. I could say numbers. Okay? This is the way I could write the numbers using the rule method. I don't list the elements. I just put a phrase that describes the elements in the set. So it doesn't list them. It usually has a phrase. I know right there I just put in a word. Phrase to describe. To describe the set. Okay? So let's talk about a few terms. Do you remember what this means? kind of looks like an E. This means element. Okay. So if I say that I better come up here. We talked about two ways to describe sets. There's the roster method or the list method. We use braces and we list the elements inside the braces. Or there's the rule method. For example, we still use braces, but we put a phrase to describe the set. Instead of putting a 1, 2, 3, ... I just put numbers here. Of course, when I put numbers, then that's going to include negative numbers and everything, but you get the idea. Some of our symbols for sets, E means element. So if I say that set B equals 4, 5, and 6, I can say that 7 is not an element of B. There's no 7 there. So E means element. E with a line through it means it's not an element. Okay? All right. So let's look at some of today's problems. One is matching. It's the vocabulary words. So we're going to start with number 3. Hoping you had a chance to do that. Sorry. Number 3. It wants, using the roster method, it wants all the months whose names begin with the letter J in order. And it shows me that there are 3. Okay? So, I would say January, well, the very first one starts with the letter J. Okay. January, February, March, April, May, June. June starts with a J. And July. Okay? All right, let's look at number 5. Number 5 is another matching one. So instead of number 5, I'll do number 6. I usually don't do the evens, but I'll do an even one with you. What does this mean? Okay. You should have said this means 9 is an element of T. 9 is an element of T. Okay. Now let's look at number 8. Okay. It gives you 6 boxes. 1, 2, 3, 4, 5, 6. Okay, there's 6 boxes. And it wants you to check each box that is true about finite sets. Okay? Are you ready? All right. Finite sets. The first box says finite sets. An example of a finite set would be all the whole numbers. Is that an example of a finite set? Can you count all the whole numbers? No, you can't. So that's not an example of a finite set. You can't count them, so that's infinite. Okay? Let's look at the second choice. Is this an example of a finite set? all whole numbers less than 1 trillion. Okay, all the numbers less than 1 trillion, that's a finite set. It's going to take a long time to count them, but, well, I guess all the whole numbers less than a trillion are 999 billion. So that would be the answer, but you can count it. Okay? Okay, let's look at the third one. All letters of the alphabet, is that a finite set? Yes, it is. You can count the letters of the alphabet. There are 26. So that's a finite set. Let's look at the next one. The entire world's population, is that a finite set? The entire world's population. Yes, it is. It's a finite set. It's not going to be easy to count it, but you can count it. Okay, this one. This one says all the odd numbers. Is that a finite set? All the odd numbers. No, it's not. You can't count all the odd numbers because it keeps going on and on and on and on. Okay? Okay, the last one is this. Is this a finite set? What did you say? You can count them. There's 0. You can count that. So that's a finite set. So we said all the numbers less than 1 trillion is a finite set. All the letters of the alphabet is a finite set. The entire world's population is a finite set. And the empty set, or the null set, is a finite set. Okay? Alright, I want you to go ahead and review your lesson and go ahead and finish the problems.